partial fraction decomposition. Wait, decompose. Even my non-mathy people, decompose. We're breaking something down, right? Right? Breaking it down, David? It's not a body. So, decomposition. I'd be in trouble if it was. Decomposition, we're breaking something down. Does anybody remember what we're breaking or how we're breaking this thingy down? Okay, we are splitting it up, kind of. Turning it into two. Tyler's back here trying to explain.
I don't know. Whatever I come from this.
Yeah. Something got put together with common denominators, right? Something got put together with common denominators, and we're trying to figure out what. What 2 or 3 or 4, well, hold on, right away I know two things. What two fractions got put together, what two rational functions got put together to make this thing? One more time, some of you guys are like, what's the point? This is silly, except it's a building block. I know, the hard thing with math is many times one skill you're learning in one class, you're not going to actually fully develop until another class or another level. It's a building block. It's a building block. You're not going to see the full picture yet. But I see the full picture, and I see these crazy calculus problems that's impossible, that are impossible to solve without this process. Okay, so we want to break it down. On Friday, we talked about how there are basically two different main strategies in order to solve when breaking down. However, some steps are the same. For instance, the very first thing we're supposed to check for, is it improper? Second thing we're supposed to do, get rid of all the denominators by multiplying both sides by the common denominator. And we kind of did that over these next couple steps. Step number 3. Improper leads to long division. If it is improper, we do long division first. Step number 2, get rid of the denominators. Step number 3, look at this system-y thing. Oh no, my bad. I missed a step, sorry. Step number 2 was to make your partial fraction. I think I'm off my step somewhere. Oh, there we go. Thanks, bud. Step number 2 is just a factor. I was way off. Just a factor. So that's down here. And then step number 3 and 4 are from each of the factors, make your partial fractions. We haven't seen any crazy ones with anything beyond A and B, but we will today. That was steps 3 and 4. Make your partials, one for each factor. That's the simplistic way of saying it. Step number 5, there he is. I lost him. He's get rid of the denominator. Step number 6 is solve. How? Either like terms, grouping together all the x terms and all the constant terms, or similarly maybe all the x squareds and all the x's and all the constants. Group together, and then have a little baby system that you solve, which is like what we got down here with the coefficients, or pick strategic values, usually from the zeros of the factors. -2 came from that guy, and 3 came from that guy. Okay? Those are our two different systems, or our two different approaches, once we get to the solving step, which is the step here at the very bottom. So what's this whole thumb tricky thing? That sounds kind of cool. This is a different problem. It's very, very similar, though. One thing I have to tell you, though, the thumb trick, sadly, is a great shortcut for the easier problems. Oh, really? Sadly, yes. But hey, wherever we can save time, we save time, right? Sound good? But once again, the thumb trick is only a shortcut for the easier problems. It does not, will not work for the harder problems. You'll see why today. But still, a shortcut's a shortcut, and it might make things a little bit easier. And once again, some of you are like, is this one of those things where you teach us how to do it the long way? And then you say, hey, it's so much easier, and we could have just done it that way from the beginning. No. Bless you. Because you need this process shown to you on a simpler problem to apply it on a harder problem. So I'm building, once again, I know math, it builds. A lot of things in life do. We need this process for harder problems. Let's go ahead and say, okay, cool, there's a short way, and what is the short way? Ready? We still start by factoring. We still start by factoring. Who's already thought about the factors of the denominator? Somebody out there. 3 and 1, x plus, sound good? X plus 3 times x plus 1, we have 4x, and yeah, we got it. we still break it down into its partial fractions, x plus 3 and x plus 1. I'm going to make a note at the very top just to kind of reinforce. Once again, the thumb trick only works with distinct, snazzy way of saying non-repeated, snazzy way of saying these factors have to be raised to the first power. They can't be squared or cubed. They have to be just raised to the first power. Distinct, aka non-repeated, linear factors. Ooh, I did not leave myself enough room. There we go. Only works with distinct linear factors, which I kind of said a second ago, that's the same thing as saying it only works with basically the simpler types of problems. And long story short, the thumb trick is basically super fast strategic value method. A super fast strategic value method. So it's going to do the exact same math as the strategic values that we wrote on the page before, the whole 4x equals and 4x equals. It's just a super fast way of doing that. And here's how it works. It's called the thumb trick because on my iPad, I could cover it with my thumb. On the smartboard, we probably would need to cover it with our whole hands. But let's just say for a moment, for a second, that we covered momentarily one of the factors. Covered it, ignored it. Kind of ignored it. Hold on, pause. Which factor am I covering first, guys? X plus 3. What is the 0 for x plus 3? Okay. So you think of the 0, x equals negative 3, as you cover. On your paper, you could cover it with your thumb. On my iPad, I could cover it with my thumb. I'm just showing you guys that covering by blacking it out for a second. We cover it up, and then we say, cool, plug in. What? Cover a factor, plug in at 0. That's the quick little summary of what to do. You cover a factor, and you plug in the 0. If you guys want steps, I don't usually write them, but that's okay. This way we at least have it. Plug in a factor, plug in its 0. So we're covering x minus 3. Sorry, x plus 3. And we're going to plug in x equals negative 3. So where? The x spot. How come? It's an x. Okay. So plugging in. If I plug in negative 3 minus 2, what do I get? Yeah, negative 3 minus 2 is negative 5. If I plug in negative 3 plus 1, what do I get? Nice. Guess what? That's A. Really? Yeah. I didn't have to multiply by common denominators. I didn't have to group like terms. I didn't have to do like solving a system. I just got to cover a factor and plug in a 0. And I have, look, what did I put it for?
A.
The same factor that I covered. Does that make sense? The same factor that I covered. Let me go ahead and get rid of all this extra work. It's going to mess us up for the next one. Oh, I like that work. Let me try to steal it. There we go. Now let's try the other one. We got this one to be negative 5 halves. Negative halves, right? Negative 5 over negative 2. What happens if I'm to cover the other factor, guys? What would I be plugging in if I cover x plus 1? Yeah, plug in negative 1. Where do I plug it into? The x spots. What's negative 1 minus 2? And what's negative 1 plus 3? Right? Now I heard back behind me, where did she just get that number from? Hold on. Who was I covering? Oh, I can't tell. Trying to pull away the right way. Who was I covering? X plus 1. What's x plus 1? 0. X equals negative 1, right? Then I plug in that negative 1 for each of the x values, and I get for this one, just so that we can attach the work to something, this is solving for negative 3 over 2. Now, there are a couple different ways of writing this. Let me go ahead and show you how the book would simplify, because this is kind of messy right now. First of all, a negative over a negative is a positive. So that's going to be positive 5 halves. Second of all, we don't like complex fractions, do we? Yeah, me either. So what we could technically do is we could look at each of these and say, hey, you each have a 1/2 that I can pull out. And we could say 5 over x plus 3. This is how the book likes to write it, because it's a little bit nicer, a little bit prettier. Both the numerators had a 1/2. Technically, they could pop down to the denominator, but we can also just pull the 1/2, the over 2, out, and then it looks a little bit nicer. But either way, dun, 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 we got our partial fractions. Did I see a question over there, John? Yeah.
Absolutely, where you like over 2 from?
Oh, because I have to plug into the top and the bottom. So when I have, over here, when I have my x equals -1, does that make sense where I'm getting that one from?
Yeah.
Okay. I'm going to plug in the -1, not only here, -1 plus 2 is -3, but I'm also going to plug in -1 here, and -1 plus 3 is 2. Does that make sense? And then for the other factor, the -3 one, -3 minus 2 would be -5, and -3, I'm plugging in the wrong one, sorry. -3 plus 1, which is underneath there, because we're plugging in the other one. -3 plus 1 would have been the -2. So you have to plug in the top and bottom. Good. How would we have had to solve this if we had done it the long way? Very, very, very similar to these. But if you guys notice on this one, the x minus 3 and the x plus 2 up here, we could have done a thumb trick on this one as well. We could have covered the x minus 3. What we have plugged in is we cover the x minus 3.
Positive 3.
Okay. If we plug in positive 3 plus 7, what do we get? 10. Positive 3 plus 2. 5. What's 10 over 5?
2.
Is that what we got? Why, yes, indeed it is. If we were to cover the other guys, double check in just to make sure we're all working. If we were to cover the x plus 2, what would we be plugging in? -2. It's -2 plus 7? 5. What's -2 minus 3? And -5. 5 divided by -5 is -1. So anyway, it's pretty spiffy. It skips all this in between work, right? But we gotta be careful of the mental math. Yeah? We gotta be careful of the mental math. Now, let's go and just practice one more of these types of problems just so you guys can see if you can do it. And get all the way there on your own, maybe talking to your group just a little bit. That one's too hard. That's inserted quick blinking. You can technically use any method, but my hint, I would just say try to use a thumb trick because it's applicable. If I was to say find the partial fractions, I'm just going to say partial fractions, or let's just say find the partials. We'll shortcut it. Find the partials, aka the partial fraction decomposition of the following. Let's do 2x plus 1 all over x squared. That won't be too mean. I was about to put a number in front, but I won't. Let's do x squared minus 7x plus 12. Alright, let's see if you guys can get there. The thumb trick is a valid technique for this one. Sorry, I moved them up. I'm going to go ahead and freeze the screen. I'm going to do it, and let's see if our answers match at the end. If it helps, literally cover with your thumb. Cover that factor you're not supposed to be looking at as you plug in 0. Mental math is hard. It's okay to do it off to the side. No shame in taking a little longer on a math fact, but always getting it right. No shame in that at all. You trying it? You plug it and shut it. It's a great shortcut. I have it, but I want to give you guys a couple seconds. Come on. Yeah, it's literally a plug and shut. cover a factor with your thumb and plug in its zeros to x values. What do you guys think? Real quick, just for those of you guys that are like, I did not follow that at all, and you didn't even know how to start. As we cover, let me cover with a lighter color so we can still see it. As we cover x minus 3, what do we plug into x? We plug in the 0, x equals 3. What's 2 times 3 plus 1? 7. Plug in x equals 3 also here. Where do we get the 3? Remember, it's the 0 of the factor that we're ignoring. 3 minus 4 is negative 1. Why did I put it over this guy? Because they have to match. When I cover a factor, I'm solving for his coefficient. And then similarly, if I was to cover the other guy, let me do it in a different color just to symbolize. If I was to cover this guy, who am I plugging in? 4. Where am I plugging in 4 to? The other x values. 4 minus 3 is 1. Plugging in 2 times 4 is 8, and 8 plus 1 is 9. 9 over 1 is 9, and why did you go with this guy? Because they have to match. So it might take a little bit of time to get used to the thumb trick, and he only works, I know, with the simpler problems, but he is an awfully nice shortcut. And to be honest, in Calc BC, AP Calc BC, the higher one, on their AP test, they are required to be able to do partial fractions, but guess what? The AP guys only give them ones they can use the thumb trick on, which is pretty nice. So in some ways, you guys are going to be practicing in the next few examples harder ones than they even need to use.
So they shouldn't.
But it's because we're learning the foundation and the idea and not just the trick. And technically on their homework, they have ones that require other methods than the thumb trick as well. Just the AP is nice to them and only gives them the thumb trick ones. Alright, let's see one of those harder problems.
Easy.
Easy, cheesy. Wait, hold on, look quick. You don't like him because he's long. You don't like him because there's a fourth over a
I
third.
don't
But,
remember the formula for factor.
hold on, we don't need to factor a fourth degree polynomial because what's step number 1 tell us to check?
Oh yeah.
The degrees. Is it improper? And when you look at this, is it improper?
Yeah.
So what's the very, very, very first thing we should do?
Now we have to log divide this now.
But the whole point is it's going to make it easier. So x to the 4th plus 2x cubed plus 6x squared plus 20x. Remember, chop off the head, it goes in the box. He drops in. The other guy's on the outside. X cubed plus 2x squared plus x. Now it's time to plug it in. Why are we doing this? It's improper. And since it's improper, long division will make the problem easier. And sometimes will make it possible where it wasn't before. You guys remember how to start long division? Can I zoom in? Is that okay? I'm going to zoom in. We ask ourselves, how many times does he go into him? X cubed times what is x to the 4th? What would you guys say?
X.
No, make it match. Make it match. Why? Because division says now it's time to subtract, right? Just so this fits a little bit better, let me write it a little bit smaller. So we have x to the 4th, x times x cubed. Remember, distribute. Go all the way down the line. So we have x times 2x squared is 2x cubed. X times x is x squared. Division says subtract, like all long division has always been for you guys. But when we have multiple terms, what do we have to make sure we do? Distribute the negative. X to the 4th's gone. 2x cubed's gone. Nice. What's left? I bring down everybody because you never really know, unless you're looking ahead, you never really know which terms you're going to use. So unlike normal, like numeric long division, I bring down everybody that's left, just so I know who's left. It's a little trick. I'll leave those arrows to explain. How many times does x cubed go into 5x squared?
A certain number
It
of
doesn't. At least not with a whole factor. So what does that mean this guy is? He's a remainder. Wait, how do we write a remainder?
Write it over the x.
First thing?
What the?
Well, that's,
Hey, it's an x squared instead of the fourth degree. That's a little better, right?
not really, because that's just a mess.
Yeah, it looks like a mess. It's a possible mess.
You stick it to the man.
Improper fraction done.
I like Ricky's idea.
Let's just go with that.
I think the calculus before you start sticking to them. We have to learn our fundamentals. So bummer, man. No, not too bad. Ready? We say our original function is x plus, now hold on, you know what? We're not breaking down, if you guys go back and look at our steps, this x plus remains. This x is fine. Who do I still need to break down into partials?
The others do.
Just the remainder. So let's just take the remainder of 5x squared plus 20x plus 6. We'll need to come back to this little whole number x up here. We'll come back to him later, but for right now, we're just trying to take the fraction. We're just trying to take what rational function remains, and that's just the remainder. However, I'm going to go ahead and factor the denominator while I'm at it, because we need to do that anyway, right? Our next step is to factor. I see a common x in everybody, so I pull them out. Wait a minute, can I keep factoring this guy? Yeah, I think so too. What can we factor that guy down to be? Maybe I don't need to write him like that. X plus 1 times x plus 1. Oh my goodness, that's the same thing as x plus 1 squared, right? We're going to learn what to do not only with improper functions, which we've already done, we've divided, check, but we're also going to learn what do we do when we have repeated, look at the directions at the top, repeated linear factors. We did the improper fraction, we dealt with them by long division, but repeated linear factors, how is it different? It's not tons different, but it is a little bit. Number one, we can't use the thumb trick. I know, sigh inwardly. Number two, we have to actually make 3 partial fractions, and here's the reason why. It's a cubic. So there are 3 different fractions that can go to form it. But if we were to go ahead and make both of these x plus 1, it's the same thing. So what's the point? Well, we actually don't make them both x plus 1. We make one x plus 1 to the first power, which we don't really need to write because anything to the first power is itself. And then we do 1 x plus 1 squared. With repeated linear factors, you have to build your way up. So you have to put the factor to the first power and then put the factor to the second or the third, all the way up till whenever you need to, or whatever you have in your denominator. This one just has 2 of them, so we'll just go to squared. And then we say, okay, according to our steps, number 1, I can't use thumb trick. Number 2, to make my partial fractions or to keep going, I have to put an A above, a B above, and then some of you will think it's more complicated than it is, just a C above, because we still just have that little linear factor. Even though we squared, we still just have linear factors of x plus 1. Now we're going to follow, there we go, our steps of how to solve. Does anybody remember where we go from here? We factor, check. We form our partials, check. Yeah, I get rid of all my denominators. I get rid of all my denominators by multiplying everybody by the common denominator, which is going to be x times x plus 1. You can write x plus 1 twice if it's easier for you. Where I do on one side, I do on the other side. On the left-hand side, that one over there. What's going to happen to my denominator? Beautiful, they're all gone, right? On the left-hand side, they're all gone. I just have 5x squared plus 20x plus 6. On the right-hand side, I need to distribute. And as I distribute, do you guys remember the pattern? For ax, who's going to cancel? Sorry, a over x. Who's going to cancel out? The x, and what's going to be left? A times the other guys. A times x plus 1 times x plus 1. If you want to write it as x plus 1 squared, that's great. I'm just trying to be super precise so that everyone can follow. As I go to B, who's going to cancel out?
X plus one.
The x plus 1 is going to cancel. Who's going to be left? Yeah, and x is going to be left, and then x plus 1 is going to be left. So I've done A, I've done B. Now it's going to go to C. Who's going to cancel out?
Just or no, X plus one squared, so.
Yeah, both of the x plus 1s are going to cancel, and they have an x remaining. If you guys want to write that all out, you can. We did the example on Friday if you want to go back and check it out. So the nice thing is, all our denominators are gone. Check. Now we got to solve. Now, I'm not going to go through and do this 2 different ways. There's not time, and you guys shouldn't need it. My question to you is, what do you want us to do? Like terms or strategic values? If you want, you can go back and look at the example. What do you want us to do? Like terms, the highlighting ones? Or strategic values? Try to get rid of people. Like terms? Okay. So like terms, I see an x squared, I see an x term, and I see a constant, right? Do we see any x squared terms over here on the right though?
Yes.
Not yet, really. Do we?
Yes.
Don't we have to kind of find them? Yeah. We have to first of all go ahead and say, wait a minute, who are you? Oh, that's right. Who are you? This is going to be a times all that, right? This is going to be x squared plus x, and that's going to be b times all that. And then we have our cx. Our x squared terms, I think I see, let's just multiply this all out. Ax squared plus 2ax plus a plus bx squared plus bx plus cx. You guys see how I just distributed my a and distributed my b? Right? Now do we see x squared terms? Hopefully. After multiplying, they kind of get clear as day, hopefully. You see x terms. And then remember, the constant is just the one without an x. Remember how we group the like terms? 5x squared has to come from, or I should say the coefficient 5 has to come from. Doesn't that make sense? The 5 that's with the x squared had to come from over on the other side, the a and the b put together, right? How else do you get the x squared term? I don't know. You can't get it from the x's or from the constants. So the 5 had to come from, the coefficient 5 had to come from a plus b. If you want, we could have written x squareds next to everybody and then like divide them away. But that's one equation that we know. What's another one that we know?
20.
Yep, 20 had to come from
2a plus
each of the coefficients of the x terms.
Plus C, isn't it?
So 20x had to come from 2a plus b plus c. Had to come from the coefficients of the x term. And then, last but not least, where did 6 have to come from? The non-x one, right? The non-x one. Now you guys could use things like circles and boxes and triangles if you really want to group them. In the sense of, I know you guys don't necessarily bring around all these different colors with you to math class. Why not? But anyway. Right? You could group it different ways like you did with combining like terms back in algebra. You might have used like different shapes to distinguish. But either way, we now have 3 of our little equations and our goal is solve. Does anybody have a strategy to solving this?
system equation.
You just
Yeah.
plug in. Everything.
And don't we kind of have a stair step? Meaning,
Yeah.
who do we already know?
Okay.
Where are we going to plug them into?
First way.
To find b. Because b is going to equal 5 minus a, and 5 minus a is 5 minus 6. b is going to equal -1, right? If you don't like how I did that, you could have just plugged straight in and gotten 5 equals 6 plus b subtract b equals -1. And where am I going to put a and b now? Into the last one to find c. So 20 is going to equal 2 times a, which is 2 times 6, plus b, which is -1, plus c. Has anybody gotten there before me? C equals?
What?
Good try.
Minus 12 is 8, and 8 plus 1 is 9.
That's the part of your basic equation solving.
It's so easy to do though, right? You gotta be aware of the little mistakes.
Yeah, but
You're
how do you get
Caleb,
3
yes.
over 11?
No, I got 20 over 11.
You divided when you should.
Yeah, do you still have an X in there?
I don't think it's.
No, he divided when he should have subtracted.
Hey, long story short, common mistake.
Oh,
Can't we go back right now to our partial fractions, guys, and say we know who they are?
you're not supposed to divide it.
Yes.
He did
Yeah,
that.
you got it.
No, he
Good.
still doesn't know what he did.
Oh,
Okay.
oh, yeah, I see it.
There you go.
Oh,
There you go.
okay.
Oh, wow, that's amazing.
No, it happens. The basic
Especially
math.
because you yelled it out. And then everybody knows that.
It's okay. Confession time. Sometimes I have a hard time remembering X and Y, like which one to graph first on like which direction to go first on graphing points. So there you go. Caleb, you can feel better. Plus. Like the 0.01, like wait a minute, do I go up or over? I figured it out, don't worry. X plus 1 squared. What am I doing? I'm plugging them
Putting
in.
it back in.
Where am I plugging them in? Well, A better go with A, B better go with B, and C better go with C, right? A better go with A, B better go with B, and C better go with C. But once we plug him in. Wait a minute. Who did I leave just kind of chilling in the cold up there somewhere?
The X.
Oh, he was a part, right? Poor little X. If we come back and review, our original function got split up into this guy. We took the remainder over, and that's what this whole ABC thing stands for. But if we're writing our final answer, we need to make sure that we don't forget the little x. So let's go ahead and go put him in and say if there are partials, let's go ahead and put in our x value to complete our answer. So we have x plus 6 over x minus 1 over x plus 1 plus 9 over x plus 1 squared. Don't forget your poor little x that was hanging up there.
So if you plugged in like 1 to that, and then 1 to your top thing, it would be the same.
This is completely equivalent to this, which is completely equivalent to this. Let's just say the very bottom one has much simpler pieces. The end game has much simpler pieces. Okay. This whole page says how to make partial fractions, but we just kind of talked about it with examples. I don't think you need it. It was from the book. If you want to check out the section, you may. If you want to check out the section, you may. We're going to end on this example. And technically, this is example. If you just see how to set them up, it's enough for you guys to tackle that homework, to fully attempt it. You might just have a couple questions. There's like a downwards parabola on my board. Has anybody seen that? I need like a board cleaner or something.
It's like a upside down smiley.
A trajectory? Oh, an upside down smiley.
There's like
So it could be
some-
long fingers, it could be the trajectory.
It's a
Or
double
the rockets.
rainbow.
Whoa, I don't think.
Stop!
Oh, you mean like
Is this improper? Yes or no?
No.
Not improper, so I'm not going to divide.
Completely proper.
So I'm going to start with factoring.
I don't know.
How do I factor the bottom? I don't know, pull out someone and comment. Hold on, wait, you gotta hang with me for like 2 more minutes. I'm factoring, right? Cool, thanks. I pulled up the common X. So question. Keep factoring. Is there anything else I can do? Oh, okay, cool. X plus 2 times x plus 2, except isn't x plus 2 times x plus 2 x squared plus 4x plus 4?
You can't
Oh, that doesn't work.
No, you can't factor that.
Oh, it's a difference of squares. X plus 2 and x minus 2. Except the problem is, isn't that x squared minus 4? It's irreducible, aka we can't go any further, aka he has to have his own partial fraction. Oh no, but he's a quadratic-y one.
He's real special, isn't he?
Well, quadratic-y ones, they don't just get constants, they get an x term and a constant. That's going back to our steps earlier of linear factors just get a constant. Quadratic factors that can't be factored anymore need a bx plus c. I might be like, oh no, the whole thing changes. And my answer is no.
No.
What am I gonna do to both sides right now?
Multiply it. Just like,
Get rid of the denominators like I did before. What am I gonna do after I get rid of my denominators? I'm gonna either use like terms or strategic values in order to be able to solve. I'm still gonna have things canceling out and things remaining. I'm still gonna have pieces factoring, or I should say reducing, and I'm gonna have pieces or factors remaining. And if you guys like the like term approach, what would you do right about now? If you like the like term approach, what would you be doing? Distributing and saying, hey, let's group together the x squareds with the x squareds. Kiddos, go tackle those partial fractions tonight, do tomorrow.
this is a new section.
It is a meeting section. If you have test corrections by the end of the day, you can wait. Test corrections, they're due on Friday. They're due on Friday. Bye, guys. Count me all.
Yeah, you know. I just buy another one of these.